Good afternoon, scholars. This is Mr. Lowe. The following is a review of the primary factoring methods that you encounter in Algebra 1 and in Algebra 2 trig. The purpose of this review is to remind you of these factoring methods as you prepare to use them with simplifying, adding, subtracting, multiplying, and dividing rational expressions. So there are 6 different methods of factoring. There's greatest common factor, there's trinomials, there's difference of cubes, there's sum of cubes, there's difference of two squares, and there's grouping. And then at any point in time, multiple of those methods can be used. So we're going to review the steps for each method along with provide examples. Please feel free to use this video as you wish moving forward. To begin, let's start with greatest common factor, or GCF. This is the first factoring method. This is the first rule of all factoring. So whenever you start, this is what you would need to use. So we look at example 1, 6m to the third minus 30m squared. First things first, find the largest number that will divide out evenly from all the terms. Keep in mind, sometimes this number could be the number 1. If you look at the example, both 6 and 30 are both divisible by 6. So we're going to divide each part by 6. If all terms have the same variable, then take out the variable with the smallest exponent. If you look at our example, you have m to the third and m to the second power. So m squared is the smallest variable. So you would take out 6m squared. You're going to divide each part by 6m squared. So if you divide each part out, 6m squared, since it's the greatest common factor, would go out in front, and you must write that. Inside of the parentheses is what you put after you finish dividing. So 6 divided by 6 is 1. M to the third divided by m squared. This is a situation in which you subtract the exponents. 3 minus 2 is 1. Minus 30 divided by 6 is 5. M squared divided by m squared. 2 minus 2 is 0, so the m's would drop out. So you have 6m squared, parentheses, 1m minus 5, or just m minus 5 will suffice. So let's do one more example of this type. 4a to the third minus 18a squared plus 32a. So the same rules apply. You look at each number, look at each term, and ask yourself what is the biggest number that can divide out. Sometimes that number will be 1. In this case, we can divide out 2 from every single term. Be careful in this case. Most people will assume that the first number is the number that divides out of everything. That's not necessarily true. All 3 terms have the letter A in it. So we're going to take out an A. The smallest exponent is x to the first power. So we're going to take out 2a to the first power, or just 2a. So if we take out 2a, the leftovers go inside the parentheses. 4 divided by 2 is 2. A to the third divided by a is a squared. Minus 18 divided by 2 is 9. A squared divided by a is just a. 32 divided by 2 is 16. A to the first divided by a to the first drops out. So that is your GCF factored answer. Now remember, GCF is the first method of factoring. We could always have to do other methods if they apply, if it applies itself. So that's factoring method number 1. Our second factoring method is the MAF method. So MAF method has a condition. You can only use it if you have 3 terms. You can only use this method if you have 3 terms. That means do not use it if you don't have 3 terms. So looking at example number 1, r squared minus 11r plus 30. Your first step is to find the GCF and to take it out. So you look at the problem, find any numbers you can divide out. In this case, nothing divides out evenly except for the number 1. You look for any variables. Variables means every single term has it. In this case, it doesn't. So your GCF is 1. But if you take out a 1, that doesn't change anything. Taking out the number 1 doesn't change anything. So you're stuck where you are. Identify your A, B, and C. So A is 1, B is negative 11, C is positive 30. Now you form your MAF. The M comes from taking A and C and multiplying them together. So 1 times 30 is 30. The A comes from moving the B value over, which is negative 11. So to find your factors, you need 2 numbers that multiply to 30 and add to negative 11. It must do both. So the only 2 numbers that would work are negative 5 and negative 6. Negative 5 times negative 6 is 30. Negative 5 plus negative 6 is negative 11. So you have your 2 factors. You divide each of the factors by the leading coefficient. The leading coefficient is your A value, which was 1. But if you divide that by 1, nothing changes. So your factors would be r minus 5 and r minus 6. The order wouldn't matter as long as you have them in your problem. Let's do another example. This time, we do have a leading coefficient, so it's going to change it up slightly. First, we look for greatest common factor. 2, 7, and 15, there's nothing that divides out evenly. S is the variable, but everything doesn't have it, so we're only dividing by 1. So again, nothing changes. Now we go to work. A is equal to 2, B is equal to 7, C is equal to negative 15. So to get your M value, 2 times negative 15 is negative 30. Your add value is simply taking 7 and moving it over. So you need 2 numbers that multiply to negative 30 and add up to a positive 7. The only 2 numbers that would work in this case are positive 10 and negative 3. Positive 10 and negative 3. So far, nothing has changed from the first example. However, your leading coefficient was 2. So that means we divide our factors by 2. So in writing our factors, 10 divided by 2 is 5. So one of our factors would be S plus 5. Negative 3 over 2 is already reduced. So you have S minus 3 over 2, but we're not going to leave a factor with a fraction. So to take care of that, we take the denominator and we move it in front of the S. So our factored answer is S plus 5 and 2S minus 3. So that gives you your factored answer. And that takes us through the review of MAF. So MAF is not really all that difficult, but it does require you to know how to multiply, know how to add to make it work. So moving on, third factoring method is the difference of two squares. Now you have to pay attention to the criteria for difference of two squares. First off, it has to have two terms. You can only use difference of two squares if your expression has two terms. It has to be separated by a minus sign, and both terms must be perfect squares. Both of your terms must be perfect squares. So make sure you give the problem a once over before you start solving it. So let's look at example number 1. 9v squared minus 25. So make sure it passes through the initial test. Two terms, we're good. Separate by a minus sign, we're good. Both numbers, well, both terms being perfect squares. So a perfect square for a number is pretty simple. That's 1, 4, 9, 16, 25, etc., etc. A perfect square for a variable means that the variable has to have an even exponent. So that's v squared, v to the 4th, v to the 6th, v to the 8th. As long as that exponent is even, then you can go ahead and potentially use it as a perfect square. So in this case, 9v squared, the square root of 9 is 3, and v squared can be broken up evenly. So that's 3v and 3v. 25 is also a perfect square. That's 5 and 5. But keep in mind, if you just take 5 times 5, that gives you positive 25, and you need a negative 25. So make one of them positive, one of them negative, and then that pretty much takes care of your factoring. 3v plus 5, 3v minus 5. So that takes care of that. Example 2 adds a little bit more to it because remember, the first rule of all factoring is to take out the greatest common factor. So if you look at 3p to the 3rd minus 192p, both numbers are divisible by 3. And both terms have a p in it. So you can take out p to the 1st power. So if you remove 3p, then you're left with p squared, 3 divided by 3, 1, 3 minus 1, 2. 192 divided by 3 leaves you with 64, and the p's drop out. So that's your first line. Now you take care of the difference of two squares. P squared, again, even exponent, so it allows you to break it up. P times P. 64 is a perfect square. 8 times 8. But remember, you need a negative 64, so one of them positive, one of them negative. And now we're good to go. P plus 8, P minus 8, and then 3p comes out in front. Remember, your greatest common factor always has to be placed into the actual answer. So do not forget it. Never forget it. So that's factoring method number 3, difference of two squares. Pretty simple factoring method, but make sure that you remember when it can and cannot be used. Next factoring method is grouping. So grouping, pretty self-explanatory when you can use it. The expression has to have 4 terms. The expression has to have 4 terms. So looking at example number 1, y to the 3rd minus 7y squared plus 6y minus 42. Has 4 terms. So we kick things off by finding the greatest common factor. I told you it was the first rule of all factoring. If you look at the whole problem, there's no number that divides out of everything evenly, and all of them don't have the same variable, so we can keep it moving. Greatest common factor is 1. So, step 2, separate the problem into 2 groups. This is pretty self-explanatory. Literally take the problem and split it in half. First 2 terms is one group, the second 2 terms is the other group. Now, you find the greatest common factor from each group. So if you look at the first grouping, y to the third minus 7y squared, you can't divide by 7, but you can take out a y squared. They both have the same variable. They both have the same variable. So if you take out y squared, you're left with y minus 7. Now that's very important that you see y minus 7 in that parentheses. You'll see in a second. Go over to the second group. Now for the second group, whatever the sign is in front of the second group, you have to pull that down automatically. So it's automatically going to have a plus sign. Now you look at the 6 and the 42. Both of those are divisible by 6. So if you take out 6, 6 divided by 6 is y, negative 42 divided by 6 is minus 7. Now, I told you the part in the parentheses was important because notice that they are matching. Notice that they are matching. So now we're prepared to write our final answer. We're prepared to write our final answer for this problem, which here is the setup for the final answer. GCF, so the GCF when you started was the number 1. Matching term, so the part in parentheses that match goes next. The leftovers are simply the parts of the problem that were outside. Y squared plus 6. And that's your factored answer for grouping. Now notice step 5 says factor the terms in parentheses again if necessary. This is a clue to check for difference of 2 squares. That's a clue to check for that because it could show up. If you look in the 2 parentheses, it doesn't show up here, but I can just about guarantee you it's a 50-50 probability it could show up. Let's look at example number 2. So example 2, same rules apply. We look at the entire problem. 2, 7, 8, 28. So the biggest number that will divide out is 1. All of them don't have an x, so we keep going. So we're stuck with what you have. Next part, separated into 2 groups. So draw a line, put it in parentheses, whatever you need to do. Out of the first group, 2 and 7 does not have anything in common other than the number 1. But they do have an x, so you can divide both terms by x squared. If you do that, x squared parentheses 2x minus 7. That's the best you can do with that one. Go over to the second group. The second group begins with a minus sign, so that comes down automatically. 8 and 28, the biggest number that you can divide out is 4. Biggest number you can divide out is 4. So we're going to take out that 4, and you're left with 2x minus 7. Now we have some things that can be made to work. So let's set up our factors. GCF was 1. The matching term was 2x minus 7. The leftovers was x squared minus 4. So now you got to make sure you check. I specifically told you that difference of two squares could show up. There's difference of two squares right there. X squared, even exponent. So that's x times x. 4, perfect square, 2 times 4. So that means the final answer is 1 parentheses 2x minus 7 parentheses x plus 2 parentheses x minus 2. And all of that constitutes as your final answer. Yes, you would need to make sure you take it down all the way. Take it down all the way. Especially when you're working with a rational expression. You want to take it down as far as you can take it. So that completes factoring method number 4, which is grouping. Notice that sometimes with grouping, GCF definitely gets used. Difference of two squares definitely gets used as well. So they're now starting to stack on each other. So please, please, please be careful. All right, so let's continue. The next two factoring methods are the sum of cubes and difference of cubes. Now, these two are very, very similar in how you solve them out. The only difference is in the formula used to solve them out. But the primary criteria are the same. You have to have two terms. For sum of cubes, it has to be separated by a plus sign. And both terms have to be perfect cubes. So it helps to know what a perfect cube is. In terms of numbers, it's whatever raised to the third power will give you that value. For example, 1 is a perfect cube because 1 to the third power gives you 1. 8 is a perfect cube. 2 to the third power gives you 8. 27 is a perfect cube. 3 to the third power gives you 27. 64 is a perfect cube. 4 to the third power gives you 64. So on, so forth. If you're dealing with a variable, so if they are variables, then somehow, some way, you should be able to break them down using cubes, which in your case would be multiples of 3. So for example, x to the third would be a perfect cube because it breaks up into x times x times x. X to the 6th, perfect cube. X squared times x squared times x squared. X to the 9th, perfect cube. X cubed, x cubed, x cubed. And you can continue down the line with regards to variables. So it helps to know what actually makes a perfect cube. So let's start with our first example. 2x to the 4th plus 16x. So first rule of all factoring, take out the GCF. So if you look at the problem, both numbers are divisible by 2. So we're definitely taking out a 2. Both terms have a variable. So we're going to take out 2x. So you have 2x parentheses x cubed plus 8. Again, it's always GCF. GCF always first. Now, find the perfect cube of each term. So we're looking exclusively in the parentheses. X cubed is a perfect cube because you can rewrite it as x times x times x. 8 is a perfect cube because you can rewrite it as 2 times 2 times 2. So since you're able to do that, we're going to take an x and take a 2 and prepare to use the formula that goes with it. So if you notice on the left-hand side, here is our formula for the sum of cubes. So the x, since it came first in the problem, will represent the A part of the formula. 2, since it came from the second part of the problem, represents the B part. So now you just have to make sure you pay attention to what you're doing. A plus B is pretty simple. So that's x plus 2. A squared means take whatever the A portion was and raise it to the second power. So x squared minus A times B. So minus x times 2, which is 2x, plus B squared, so that's 2 to the second power, which will end up giving you 4. So your final factored answer is 2x, because that's the greatest common factor you took out at the start of the problem, parentheses, x plus 2, parentheses, x squared minus 2x plus 4. And that makes up your factored answer. So again, it's not a difficult problem, but it is a problem in which you have to pay attention to what you're doing step by step by step. Let's do another potentially more complex example. 125 n to the third plus 27. So first thing to note, there's nothing that divides out of 125 and 27. So that's 1. They both don't have a variable, so all you're taking out is 1. So nothing changes. Now we look at each term. 125 is a perfect cube because that's 5 times 5 times 5. N to the third power, n times n times n. 27 is 3 times 3 times 3. So we have what we need to start the sum of cubes formula. 5n will be the A part, and 3 will be the B part. So now we're set and ready to go. A plus B is 5n plus 3. That part's finished. A squared. Now here's the tricky part. Notice that A has 2 terms in it, a 5 and an n. That means both parts have to get raised to the second power. 5 to the second and n to the second. You got to do it to both, so just be careful. Minus A times B, so that's 5n times 3, plus B squared, so 3 to the second power. So all that's really left is just simplifying. Your greatest common factor when you started was 1, so that carries over. Parentheses, 5n plus 3. Parentheses, 5 squared is 25. N squared is n squared. 5n times 3 is minus 15n. And 3 squared is 9. So that makes up your entire factored answer. So again, a little bit more work involved. So pay attention to what you're doing. Take that extra bit of time so that you can see what's going on. That's sum of cubes. Difference of cubes is the same set of rules. The only difference with difference of cubes is the formula changes. The only thing that changes is the formula. More importantly, the signs inside of the formula. So that's really the only difference between sum of cubes and difference of cubes. So we're going to roll right on into examples with difference of cubes. W to the third minus 27. Remember, check for GCF. You have a 1, you have a 27, so you're dividing by 1. They both don't have a variable, so we're stuck with what we have. W to the third is W, W, W. 27 is 3, 3, and 3. Notice that I didn't do anything with the sign. You don't have to. The formula takes care of that. So that's one less thing that you have to worry about. So the W is your A term. The 3 is your B term. And we can start factoring it out and being done with the problem. So to kick things off, you have A minus B. That's W minus 3. That part's finished. A squared, take W squared, plus, there's one difference, A times B, so that's W times 3, plus B squared, so that's 3 squared. Then we simplify and finish everything off. W minus 3, parentheses, W squared plus 3W plus 9. And then don't forget that 1 that you took out at the start of the problem. So that's it. That's all that's factored. Second example. Second example, same rules apply. Look for greatest common factor, which this definitely has a greatest common factor. And that greatest common factor is the z's. You can divide both parts by z squared. You take out z squared, you're left with 8z to the third minus 125. And always look for a greatest common factor. It could save you a headache. Go inside the parentheses and do a little work. 8z to the third. 8 is 2 times 2 times 2. Z to the third. Z times Z times Z. 125. 5 times 5 times 5. Again, you don't have to worry about the sign. The formula takes care of it. Formula takes care of the sign. So 2z is the A portion, 5 is the B portion, and now we're ready to do some work. A minus B is 2z minus 5. A squared, so remember from the last example, you have two terms, so 2 squared, z squared, plus A times B, so that's plus 2z times 5, plus B squared, 5 squared. So now we're ready to simplify and be done. The z squared that you pulled out at the start of the problem, make sure you bring that back into the answer. 2z minus 5. And then 2 squared is 4. Z squared is z squared. 2z times 5 is 10z. And 5 squared is 25. So that is your factored answer. Now, if you noticed in the sum of cubes and in the difference of cubes, there's this term that has, one of the parts has three terms to it. Notice that we haven't tried to do MAF to that part because 99.9% of the time, it doesn't MAF. For example, for the problem that we just did, you're trying to find two numbers that would multiply to 100 and add up 10, which aren't there. For the example before it, you're looking for two numbers that multiply to 9 and add up to 3, which aren't there. So you're pretty safe in just leaving those parts alone. So that's sum and difference of cubes. Again, they're not hard. They are work, but they're not hard. All right, folks. So the last part in this factoring review focuses on factoring polynomials completely, this is pretty much the name of the game. Factoring completely means using any and all ways to get all of the factors of a polynomial. So that means you take it down all the way. Factoring does not mean find out what x is equal to. That's called solving. That's called solving. So there's a difference between factoring, just getting all the factors, and solving, finding out what x is equal to. We're just worrying about factoring. So to complete this task, we start where else? With the greatest common factor. Start with the greatest common factor, if there is one. Then you look at the number of terms remaining and use the appropriate method. So if you have two terms left, that's either difference of two squares, sum of cubes, difference of cubes. 3 terms is MAF. 4 terms, grouping. And then after you finish whatever method, you look at your factors and see if anything else can be done. So sometimes after greatest common factor, there might not be anything else you can do, and that's it. And that's okay. Sometimes you may have to do GCF and MAF. GCF, grouping, and MAF. GCF, sum of cubes. So expect that any problem could have to be factored multiple times. Don't get scared of it, just be aware of it. Let's look at the 4 examples that are included here. So the first example, 8m to the third minus 50m. So again, first rule of all factoring is to look for GCF. In this case, 8 and 50 are both divisible by 2. And you can take out an m. So that leaves you 2m parentheses 4m squared minus 25. So 2m is done. You can't do anything else with that. Now we're going inside of the parentheses. 4m squared minus 25. Notice that you have 2 terms. So we have to see what option works. Although this one is pretty easy. Since the exponent is 2, that eliminates sum of cubes and difference of cubes right off the bat. So it's either going to be difference of 2 squares or nothing at all. So difference of 2 squares means you got to have perfect squares. 4 is a perfect square, 2 and 2. M squared is a perfect square, m and m. 25 is a perfect square, 5 and 5. And remember, one of them has to be negative, plus 5 and minus 5. So your factored answer is 2m plus 5, 2m minus 5, and don't forget the 2m that you took out at the start of the problem. That's your factored answer. So notice in this problem, we took out GCF, and then we ended up using difference of 2 squares. 2 different factoring methods to solve out this problem. Factor completely. So let's move on to our second example. 2n to the 4th plus 8n squared minus 64. So again, the same rules apply. First rule of all factoring is GCF, greatest common factor. We look at each term. You have a 2, you have an 8, you have a 64. So everything is divisible by 2. However, you can't take out an n because All the terms don't have it. So 2 parentheses n to the 4th plus 4n squared minus 32. So notice our first line of defense is greatest common factor. So the 2 is done. We have 3 terms inside the parentheses, so this now turns into a MAF problem. So we launch into MAF. A is equal to 1, B is equal to 4, C is equal to negative 32. So when we do our MAF, we're looking for 2 numbers that multiply to negative 32 and add up to a positive 4. The only 2 numbers that are going to work are positive 8 and negative 4. Since the leading coefficient was 1, we would divide both of them by 1, but that's not going to change anything. And also notice that you have n to the 4th power. So n to the 4th breaks itself down into n squared and n squared. So our factors become the 2 that you took out at the start of the problem, n squared plus 8, and n squared minus 4. So that's our factors, but now you need to check. The 2, nothing else you can do with. N squared plus 8, nothing else you can do with. N squared minus 4 is difference of 2 squares. So we need to finish this off using difference of 2 squares. N squared is n times n. 4 is 2 times 2. Positive 2 and a minus 2. So your final answer is 2 parentheses n squared plus 8 parentheses n plus 2 parentheses n minus 2. So all of that is your factored answer. Again, you go through all the possibilities to make sure that you are down to the bare bones nitty gritty. In this case, we had to factor 3 times: GCF, MAF, and difference of 2 squares. And that ultimately gets us to our final answer. Third example. So third example, we've got 40 a to the 3rd minus 60 a squared minus 10a plus 15. Again, first things first is greatest common factor. If you look at all 4 terms, every single term is divisible by 5. Every single term is divisible by 5. So that's what we're going to do first. Divide everything by 5. Divide everything by 5. You can't take out an a because the 15 didn't have 1. So you have 5 parentheses 8a to the 3rd minus 12a squared minus 2a plus 3. So the first thing we did was take out the GCF. Now notice you have 4 terms. So 4 terms means we now follow grouping. Separate into 2 groups. First group, 8 and 12, you can divide out 4. A to the 3rd and a squared, so you can take out a to the 2nd power. So if you take out 4a squared, you're left with 2a minus 3. You're left with 2a minus 3. Move on to the second group. The second group, it began with a minus sign, you pull down the minus sign. 2 and 3, there's nothing that divides out of 2 and 3 other than the number 1. Like I said, 1 is fine. It is what it is. If you divide by 1, 2 divided by 1 is 2, so that's 2a. since you took out a -1, 3 divided by -1 is -3. Be careful with that negative sign. If you notice your parentheses don't match, chances are you forgot the minus sign. So to finish off grouping, 5 you took out, so that comes first. The matching parentheses go next. Your leftovers go last. Leftovers go last. So now it's that time to check and make sure that you did everything correctly. So 5 you can't do anything else with. 2a minus 3 you can't do anything else with. But 4a minus 1, you have 2 perfect squares. So there's a difference of 2 squares. Square root of 4 is 2. A squared is a times a. The square root of 1 is 1. You need 1 positive, 1 negative. So your final answer, 5 parentheses 2a minus 3 parentheses 2a plus 1 parentheses 2a minus 1. So again, we used 3 factoring methods again. GCF, grouping, difference of 2 squares. Let's do one more example, and that will finish you all off with examples. Z to the 5th minus 3z to the 4th minus 16z plus 48. First rule of business, greatest common factor. So in this case, there isn't anything that's going to come out. There is no number that will come out of everything, and everything doesn't have a z. So the only thing you can divide by is 1. Thus, nothing changed. Nothing changed. You have 4 terms. Breaking into 2 groups because now you're going to group. So outside of the first group, you can take out z to the 4th. So if you take out z to the 4th, you're left with z minus 3. Move on over to the second group. You can take out a negative since it started with a negative. 16 and 48. Again, make sure you get the biggest number, otherwise you're going to be doing this multiple times. Take out a 16. So if you take out the 16, you're left with z minus 3. Their parentheses matched, so you did everything correctly. So let's go ahead and write our factors. 1 comes down. Z minus 3 was shared. Z to the 4th minus 16. Z to the 4th minus 16. Now we check. 1 you can't do anything to. Z minus 3 you can't do anything to. That third factor, you should have guessed that it's probably difference of 2 squares. So z to the 4th is z squared and z squared. Remember, any multiple of 2 qualifies under difference of 2 squares. Square root of 16 is 4 and 4. One of them positive, one of them negative. So that gives you 1 parentheses z minus 3, z squared plus 4, z squared minus 4. But don't get caught up. Z squared minus 4 is still difference of 2 squares. So we'll do difference of 2 squares again. z and z, plus 2 and minus 2. So 1, z minus 3, z squared plus 4, z plus 2, and z minus 2. That's all of your factors for that problem. That's all your factors for that problem. Yes, there's 4 different terms sitting up there, but none of the factoring methods change. You just have to be patient enough to navigate through the problem. But that completes the review of all of the factoring methods and how to navigate it when all of the methods can be used at any point in time. It's on you to now review, put in the time and put in the effort, and ask questions as needed. With that, good luck.